This lesson is going to cover what's called conditional probability. It's our second learning target in our topic on probability. Learning target 2, I can calculate the probability of a conditional event. The first thing we need to do is understand the difference between dependent and independent events. A dependent event is an event when one event affects the possibility of another event happening after or at the same time. The key word you should look for to figure out if a certain situation contains a dependent set of events is the word without replacement. Our second type of event is the independent event. And independent events are events that do not affect each other. A key word to look for is with replacement. An example of dependent events would be taking cards out of a deck one at a time. An example of independent events would be, say, flipping a coin, where one flip doesn't really affect the outcome of the second flip. In order to do conditional probabilities, we need to know what to do when we see the word or within the prompt of a probability problem. We call this the addition rule. The key word you look for is or. If you see the word or, you should add and then subtract the overlap in the probabilities. This is our formula for doing the probability of one event or another event. The key part here is that you find one probability and then you find the probability of the other event. You're going to add them together, but then you're going to subtract the probability of those things happening together simultaneously. We could understand this rule with Venn diagrams. The probability of A is all the ways that A could happen. The probability of B is all the ways that B could happen. But there isn't always an overlap in our Venn diagrams. This is the part that you need to subtract to get your final probability of one event or the other. Let's try doing a OR probability with a spinner. What's the probability of this spinning and landing on an even or a multiple of 3? Well, there are a total of 1, 2, 3, 4, 5 even out of 10. We're going to add this to the probability of multiples of 3, which would be 3, 6, and 9. So that's 3 out of 10. Are there any even but also multiples of 3? There are. The number 6 is both an even number and a multiple of 3. So we are going to subtract that probability as well. 3 plus 5 is 8. 8 minus 1 is 7. There is a 7 out of 10 chance of the spinner landing on an even or a multiple of 3. This is approximately 0.70. Let's do a playing card question. A card is randomly selected from a standard deck of 52 cards. What is the probability of it being red or a king? So the probability of red would be 26 out of 52. The probability of pulling out a king would be 4 out of 52. Now, I'm going to subtract the probability of both pulling out a red king. And the probability of pulling out a red king would be 2 out of 52 because there are 2 red kings, the diamond king and the heart king. So 26 plus 4 is 30, minus 2 is 28. So 28 out of 52 comes out to approximately 0.54. So close to 50% chance of pulling out a red card or a king. What's the probability of pulling a heart or a face card? Well, there are 13 cards that are hearts. There are how many face cards? That would be all the cards that have the jack, the queen, or the king. Aces don't have a face on it. Only the jack, queen, and king have a face on it. And there are 3 of those in each of the suits. So 3 times 4 is 12. There are 12 cards with faces on it. How many cards have a face and a heart? That would be the jack, queen, and king of hearts, 3. So 13 plus 12 is 25, and 25 minus 3 is equal to 22 out of 52. This is approximately 0.42, a little less than half this time. The multiplication rule. This is a rule we use when we have 2 events that are happening in more of a sequential order, one event happening after the other. The key word we look for in the prompt is and. So if you see the word and, you're going to be multiplying the probabilities. The probability of event A times the probability of event A times the probability of event B. You are rolling one 6-sided dice twice. These would be called independent events, the roll number 1 and the roll number 2, because rolling a dice once does not affect what the outcome of the second roll would be. But we can still do an and probability with these. What is the probability of rolling a 6 the first time and a 3 the second time? Since the key word here again is and, we will be multiplying. How many 6s are on a 6-sided dice? There's 1 out of 6. We multiply this by the probability of getting a 3. There is 1 3 out of 6 sides. There's a probability of 1 out of 36. Remember, when you're multiplying fractions, you multiply both the numerators and the denominators. 1 out of 36 is equal to 0.03. This is a very small chance that you would roll a 6 and then a 3. What is the probability of rolling a even the first time and a multiple of 3 the second time? 2, 4, and 6. There are 3 different ways to roll an even number out of 6. A multiple of 3. There's a 3 and a 6 on the die, so that'd be 2 out of 6. 3 times 2 is 6. 6 times 6 is 36. This is a 1 in 6 chance, 0.17. Still a very small chance of rolling an even number the first time and then a multiple of 3 the second time. What's the probability of rolling a even the first time and an odd the second time? Rolling an even the first time would be 3 out of 6. The even numbers are 2, 4, and 6 on the dice. Odd numbers would be also 3 out of 6, 1, 3, and 5. Multiply these together and I get 9 out of 36, which reduces down to 1/4, 0.25. A much bigger chance of getting these 2 rolls than getting my other rolls. A bag contains 5 marbles and 6 blue marbles and 4 green marbles. You pull out 1 marble and without replacement, you're going to then draw out other marbles. These are what we call dependent events, because as we pull out marbles and we don't put them back, it decreases the amount of marbles there are in the bag to pull out. So what's the probability of pulling out a red marble the first time? Well, 5 plus 6 plus 4 is 15. There's 5 red marbles out of 15. We have a keyword of and, so this is multiply. 5 over 15 was the first red probability. Pulling out a red the second time, we need to assume that we actually did pull out a red marble. There's now 4 red marbles in the bag. Since we're not putting back that first marble, that means there's no longer 15 marbles in the bag when we pull out another marble. There's now 14. 5 times 4 is 20. 15 times 14 is 210. This reduces down to 2 over 21. In decimal form, it is 0.095. Very, very small chance. What's the probability of pulling a blue and then a red and then a green? There are 6 blue marbles out of 15 to begin with. There are 5 marbles, but now it's out of 14 because I pulled one out. And then green would be 4 marbles, but now it's out of 13 because I've pulled 2 out. This comes out to 120 over 2730. A very small chance of 0.044. Okay, that covers examples that show you the differences between independent, which would be with replacement, and dependent, which is without replacement. We also talked about the OR rule, which is addition with subtraction when needed, and the AND rule, which is multiplying probabilities. Don't forget to hit the submit button so I have a record of you participating in the video.